The Steamboat may be the world's largest geyser, but it doesn't dominate the Norris Geyser Basin as expected. The only thermal feature directly affected by Steamboat is Cistern Spring, which drains its water every time the geyser erupts. When Steamboat erupts, Cistern is the only one who reacts. Other features around it don't change, so Steamboat is relatively independent, says Michael Poland, scientist in charge of the Yellowstone Volcano Observatory. If there are changes at Steamboat, Poland believes the answer lies in the intricate underground piping system that circulates 160-degree hot water through its vents during eruptions. Even small changes in the piping can permanently alter a geyser's behavior. Poland says many geysers in Yellowstone exhibit this behavior. A geyser may be active for a time, then change its activity pattern or become completely inactive, only to reactivate after a period of dormancy. This is part of the dynamic nature of geyser activity in general and Yellowstone as a whole. Poland believes that changes to Steamboat's plumbing system have likely facilitated these frequent eruptions. The exact nature of these changes and their causes remains uncertain. It's simply a function of how the geyser's plumbing system looks now, which may be slightly different from what it was a few years ago. A variety of sensors, gauges, and other equipment monitors the activity of the Yellowstone thermal basin. Technological advances have provided incredible insight into the complex geological and hydrothermal world that can't be seen from the surface. An acoustic sensor was installed at Steamboat, allowing scientists to monitor geyser activity through acoustic energy. A flow meter monitoring the Tantalus River can measure the amount of water Steamboat releases after an eruption. All water from the Norris Geyser Basin flows through the Tantalus River and then empties into the Gibbon River, Poland said. About 90 minutes after Steamboat erupted, we could monitor the volume of water it released before it entered the Gibbon River. However, none of these devices is 100% foolproof. Strong winds can confuse acoustic sensors, and flow meters are less reliable if Steamboat erupts during rain. We have a seismometer at the Norris Geyser Basin Museum, about a quarter-mile from Steamboat, to measure seismic energy. We can record Steamboat quite well during the summer. Still, when it snows heavily in the winter, the seismic signal is dampened because the snow covers the ground. Poland emphasized that, although technology has advanced significantly, understanding or anticipating geyser activity remains a complex science. Much information about Steamboat geyser activity is being collected, but interpreting or drawing conclusions from that data can take years. Is Steamboat Geyser entering a new normal with significant eruptions every few months? Or is it just having trouble sleeping? Based on its current activity, Poland gives it a 50-50th chance. The odds may or may not be the same at this point. It would be interesting to see if Steamboat enters a phase where it erupts every 2 or 3 months. From Poland's perspective, the real value lies in the vast data collected on Yellowstone's geological and hydrological activity. This data forms the basis of ongoing research and will provide valuable insights for future analysis. The most predictable thing about Steamboat Geyser is its unpredictability. No one can be certain what will happen until it happens. However, anticipation for the next eruption is already growing.